What? Hmm? What? What did I do wrong this time? Oh, it's looking fine to me. Do you want to come and tell me? Do you want to come sit here and do the work so I can stand there and tell you what to do? I think that's a better job to do, right? I'll be a lot happier. It's working just fine. What's wrong with it? I don't see anything wrong with this. It's an attribute. Yeah, I mean, doesn't the whole world use attributes? All right, whatever. My gosh. I tell you, some people, seriously. What's up, YouTube? In today's episode, we're going to be looking at custom attributes. So what are custom attributes? Well, they are attributes, and I hope you know what attributes are in .NET. These are custom, as in we can build our own or define our own classes that are attributes, and they're called custom attributes in .NET. So we're going to be looking at building our own custom attributes, the how, the why, the when, and all those kinds of things. So in order to set the stage for custom attributes and for you to be able to understand when and how and the why, I have a business scenario in mind that I will try to explain. And then based on that, we will build out the code, and hopefully that'll help you understand the point or the reasoning behind custom attributes. So here's the scenario. We are in a business that works with movies, and movies have a genre. So, and a genre is things like action, drama, horror, fiction, science fiction, thriller, and so on. And we've determined that the genres are going to be an enum in our system, which is very common. I mean, the idea that you have a set of finite things in a business that end up becoming an enumeration inside of your code. We have to be able to convert string representations of an enum and map it or parse it to an enum in our system, right? What's that? Enum? Why? How do you say number? Right. So then it's enum, right? By the way, it's enum in C# and it's enum if you're in America. But in C# we say enum. Okay. So strings need to be parsed to our enum, and enums need to be converted to strings. Now this sounds all okay, and you don't need to do anything to get that to work in .NET. You just say enum.parse and that'll parse it. And similarly, you can, if you have a enum variable in your hand, you can say .toString and that'll convert that to a string. The problem comes when we have a genre like science fiction that's frequently represented as sci-fi. And in most languages, you cannot have enum elements that are with spaces or with hyphens. So they have to be a contiguous string. And therein lies our predicament. Well, it's not a predicament, is it? Because we got a solution to that problem. But I'm sort of setting the stage here. So now we're going to be working with just the sci-fi genre or the enum element specifically, and I'm going to go through the process again. So we have to convert the string sci-fi to map it to, so I didn't mean convert, map it to the enum sci-fi. So in our enum, we'll have the element sci-fi, as in one word, but a string of sci-fi or sci-fi needs to map to our enum sci-fi. And conversely, when we have something that is got in the genre of sci-fi, it needs to be, the string representation of that needs to be sci-fi. All right. So I hope that makes the requirements clear. The difficulty is that we can't just do enum.parse. In C# that won't work, and we certainly can't have an element sci-fi in our enums. But then sci-fi is not good enough for the business. So you're trying to stick to business vocabulary, and that's when this sort of thing comes in handy. You should know that I have a love-hate relationship with attributes, but hold that thought. Do we have to use attributes for this as a solution for this problem? Absolutely not. Why are we doing enums then? Why are we doing attributes then? Well, I mean, how would I make this video otherwise? Custom attributes are a feature of .NET. They're an important feature. They come in handy every once in a while. But for the purposes of this video, we're using attributes or custom attributes as a solution to our problem. There are other ways, and we can, hold that thought to the other ways part. All right, so let's just jump right into code and see what we have. So what I have here is a blank .NET Framework application. It doesn't matter whether it's .NET Framework or .NET Core. They'll both work just fine. For the sake of brevity, I'm going to do the coding, but it'll be like super duper fast. I mean, I'm like a speed coder, so you won't even, it'll be like a blink of an eye. And then I'll explain whenever I need to explain the code that, I think will need explaining. And then when we run the application and sort of test it out, I'll give you like a debugging experience. I can show you the result of something that are slightly complicated to comprehend if you've never done reflection or custom attributes before, right? Okay, so the step one is we need a genre enum. So that's our genre enum. We also need an attribute class. Custom attributes are nothing but a class that descend from the base class attribute, right? And these custom attributes the class names must end in the suffix attribute. So let's do that. So we're going to call that enum description attribute. Description attribute. All right. And this class, please make sure all your classes are internal sealed. It's not a requirement for attributes per se, but that's my requirement. Okay, so we have an attribute. Great, that's it. Now let's go back to our enum here. What I'd like to be able to do is I would like to specify that the sci-fi should be the sci-fi element should have some way for us to tell it that, hey, if you see a string of sci-fi, you map it to yourself, something like that, all right? But how do we do that? So we have the enum here, but what we would like to say is something like this, right? We'd like to say sci-fi like that in some form or fashion. Now, it turns out that this syntax, even though it doesn't look like it, I mean, why wouldn't it look like what it's supposed to be? This is a constructor. We don't have a constructor for our enum description attribute, so let's do that. Let's define a string argument. Let's call it description. And we also define a public read-only property called description. And property. Now, if you're not familiar with the syntax, then this is just new in .NET 7. I forget what version of 7, or maybe it was 6. I don't know. So this is a read-only property. It's not a get-only property. It's a read-only property, very different beast. And if you don't know how that magic works, look at my C# loading video, and you'll see the reason for why this works in the new versions of C#. Okay, so going back to our genre, we now have the ability to define a constructor argument. As you can see, this is nothing but the constructor argument. This is saying string description, just like we had defined in our constructor. Are we done? Are we done yet? No, of course not. If that was that simple, I wouldn't be making a video on that. I'd just post like a one line in a comment somewhere or something. All right, so but we're getting close. I'm going slowly here in this stage intentionally so that it's not so confusing. So our attribute is done. It seems to be not complaining. The compiler is not complaining about anything so far, but the attribute is not doing anything yet, and that attribute potentially will not do anything yet. We might have another scenario here that we say, okay, well, what if somebody puts in sci-fi as a string? Should sci-fi not map to that? Now, there's two ways to that. We could say, well, it should map. So we could say that the string sci-fi or a string sci-fi, the string sci-fi, and the string sci-fi should map to sci-fi, because on the one end we have an attribute that says sci-fi, and the element itself is sci-fi. Right? So we could write the code that kind of does both of these things. That's possible. That's doable, and nothing wrong with that. But what if we wanted to be able to do something like this? What if we wanted to say that? Just so it's clear, nobody has to look at the implementation. It's clear that these two strings should map to that enum element. The enum description has this red squiggle, and it says duplicate enum description attribute. In other words, it's saying you can't put two of those attributes on the same thing, in this case, the genre element. We have a solution for that, and that is our attributes need to be decorated with the attribute usage attribute. Okay, and I'll explain that as I write the code out so we can take a look. So we flip back to our here. So this is an attribute, and it's called attribute usage attribute. And it has a constructor argument that says, first of all, what's the target? So attributes can be decorated on classes, they can be decorated on methods, they can be decorated on method arguments, return types, and so on and so forth. Target is where we want to confine our attribute to be used only on enums, as closely as possible on enums alone, right? So it is our responsibility as people who are writing the custom attribute to ensure that our custom attribute is used in the places it's supposed to be used on. That's what we are doing over here. So we're saying the attribute targets a field, but there could be all these other targets, classes, methods, return value, all, assemblies, constructor, and so on and so forth. And another argument, optional, is allow multiple. So we're saying true. And if you just go here and look at our enum elements again, magically, that red squiggle has disappeared. All right. So that's why our attribute class needs to be decorated with an attribute itself. Remember, attributes can be decorated on classes. And so what we've done is simply that. This is our class with the description property, and we decorated the class with an attribute called attribute usage attribute. Now, whenever you do define and decorate something with an attribute, you don't need to provide the suffix, but it is there. Right? This also works. But the compiler, the C# compiler, you can see has changed the color here. I'm not sure you'll be able to see this color by the time YouTube gets done with this video encoding. But it's dimmed down a bit, so you don't actually need it. It's optional. All right. So our genre has now two attributes defined on it. And we're saying essentially the string sci-fi should map to the element sci-fi, and the string sci-fi should also map to, sci-fi should also map to the element sci-fi. Okay, we're still not done yet. How would we want to use this feature? We certainly don't want to say genre dot and a toString. We could kind of pull it off, but how do we do the other way around, the parsing part, right? You can't add methods to a genre. To an enum. Enum? No, enum. All right. So what we are going to say is that we want to have a genre parser class, and this genre parser class is going to parse for us all the genre parser class is going to do a couple of things. It's going to take string representations and parse them to the genre enum, and it's going to take a genre enum and toString it or convert it to a string representation. But when it does that, in our case, the element sci-fi should be, the string representation of it should become sci-fi, right? Keep that in mind. And towards that effort, or towards that end, we will define a class called genre parser. So let's do that. Now, all we got to do is some magic. Okay. Let me just fix up this code and then I'll explain at a high level what this code is doing. Anything else? Do that. We don't have an exception. So let's define an exception class as well. Okay. All right. So this error is saying initialize all static fields inline and remove the static constructor. If you don't know what static classes are, please look at my video on performance and memory, .NET memory and memory allocations, the memory map and performance. I'll put a link up here for that. And in there, I explained to you static classes and type instances and so on and so forth. You're going to need to understand the type instances and static classes. So in order to use a static, when we use a static constructor in .NET, their guidance is, well, try and not do that. And so what's really saying, their message is saying, do all of this, all this logic, if you will, in here. So, this is the member initializer. In this case, it's a static member, so this will be the static member initializer. So essentially it's saying, set it up over here like that. Now, of course, because we're doing so much of complicated code, we can't just, it's not a one-liner, so we can't actually do that in our static member initializer. So it's not saying or seeing what that is. So let's see what we need to do to get rid of the error message. Yeah, we do that. Now there's always a justification here. Please be sure to fill this in correctly. So what we're saying here is, we're going to say there is too much going on here, and so we can't put all of this in the member initializer. Be very clear about why you are suppressing a certain problem or hint that you're getting from either the code analysis or any other tooling that you have. All right, so now let's go through this class and explain some of the issues or some of the things here. In the static constructor, the reason we are using the static constructor is because static constructors will run exactly one time, guaranteed, in your app domain. In other words, it won't run more than once. So we're doing some heavy lifting up front, and that way we won't have to pay the price for reflection. What's wrong with the reflection? Well, weren't you holding a thought? Yeah, well, continue holding the thought. I'll get back to reflection after the end of all of this. So when you do a type of on a on some sort of a type, we get a type instance. So type of gives us an instance of the type. And once we have an instance of the type, it's just a type. It's just a regular instance, but it's an instance of a type. It has properties and methods on it. And one of the methods, one of the many methods, is get fields. The get fields takes a bit flags enum. That's a bit. So did I say bit flags? Binding flags enum. That's in this case is bits, as in this is a flags enum attribute. I have a video on flags enums. If you want to understand what flags enum is about, you can take a look at that video as well. So we want to get all the public fields and all static, as in not instance fields, but static. And this is a different understanding of that. So once we have a collection of field infos also is a runtime phenomenon, if you will. Sorry, reflection phenomenon. Once we have the collection of field infos, we can iterate over the collection of field infos. Field infos is nothing but, for each of these, we get a collection of field infos. So the field infos is the runtime type information on each of those field info, each of those fields, the elements as we call it here. So there'll be runtime type information for each one of these things. And we're iterating over that collection and trying to discover some information about each of these elements. And so here we go for each field info, which is the singular. We say get value, and get value essentially then casted to a genre will give us the actual genre. So we went from a type instance of action, we get the value of that and cast that to a genre, and we have a action genre. Sorry, yes. Well, we have a action genre, exactly. All right. And so we do that for each of these elements here, and for each genre, we can also get with the same field info, since this is giving us access to the RTT, the reflection thing, we can say get custom attributes. So in other words, going back to our genre class here, if you're reading over this collection, as we're on each of these elements, we're saying, hey, can you get me your custom attributes? We're asking this thing at runtime, give me your custom attributes, the collection. Of course, it's going to return empty collections of attributes here, empty array, if you will. And then for this sci-fi element, we'll get 2. And once we have a collection, so again, I said this could be null, or it could have some elements in it. So if the length is equal to 0, then we know what to do. What do we do? If the length is equal to 0, the string representation and the enum element should map. They should match, right? They're exactly the same. So if that is the case, then we add to these dictionaries. Now let me go up here and explain the dictionaries. So these are read-only dictionaries, and there's 2 dictionaries we have. So imagine if you were to memorize all the data we gathered from this method here, the constructor here. If we did all of that upfront and build a cache, in-memory cache of this data, then we wouldn't need to do this over and over each time. Right? So because reflection is slow, we are trying to in some ways optimize our usage of reflection so that we don't take the performance hit. In order to do that, we need to have, we don't need to, this is my design. I've chosen to have 2 dictionaries. A dictionary that goes from a string representation to a genre. So sci-fi should go to genre. Sci-fi should also go to genre, but since sci-fi and sci-fi are 2 different strings, the dictionary won't complain about them being duplicated. The right-hand side or the value part can be duplicated, but that doesn't really matter for us in our situation here. And then we have another dictionary that goes from genre to string mapping. So remember, the genre is unique, and we want to say, okay, for each of these genres, what's the string mapping? And once we've discovered which ones have attributes and don't have attributes and what the constructor values or the description property is, we'll build up this dictionary. And so basically these dictionaries will be populated once the static constructor has completed. In other words, once we have an instance of the genre parser, which is a static type instance, by the way, it's not a instance. In our code, we should be able to say genre parser.parse and give it a string. It should give us back an enum, and conversely, given an enum, it should give us a, let's say, true description method that gives us the description of that enum. So in our case, the enum element sci-fi should return a sci-fi string, right? So that's the basic idea. And in order to do that, we are looping through this collection, and we are building up both the dictionaries. We are going from, for the string to genre mapping, we're saying for every field info's name and toLower, we also want to be case insensitive. We are stuffing the name in lowercase form as the key, and the genre is, of course, the genre that we took out over here. And for the other dictionary, the genre to string mappings, we say for this genre, the name should be the string representation of that attribute that we just picked up, right? So if there are multiple attributes, then this is for the 0 case. Sorry, so length of 0, empty, right? And the case where the length is greater than 0, then we come here and we do the rest of it, which is we're really essentially just building up our map, our two dictionaries, doing that kind of upfront. Where we add in this dictionary, we map the string representation of the genre. So it's the description property, right? In the case of the length being 0, we have no need for attributes. In other words, when the cases are any one of these elements, not the sci-fi, but this and the 3 on the top here, then do the following, this part here. Essentially just directly takes the name of the field info, gets the lower version of it to make it case insensitive, or our search is case insensitive, and adds in the genre. This genre to string mapping says, here's the genre, and I want you to get me to add to this dictionary, I want you to add the name. So it's the genre to string mapping. And this dictionary will be used when we say, given an enum genre, get the string representation of that, that's when this will get used. Right. Now, if there are more than one custom attributes found, so the length is greater than 0, then we but we go down this path. We were first doing the genre to string mapping for the same genre. What's the string? Well, if the genre is sci-fi, the string representation should be sci-fi, right? And then, we can get multiple custom attributes back. So for each of those, for each of our custom attributes collection, we have a enum description custom attribute, enum description attribute. And for each of those, we want to add to our string to genre mapping. So you have string key to genre value mapping. For the given string over and over, the description of the enums, the collection of attributes here, we want to add the genre. So remember, the dictionary allows or forces us to have the key has to be unique. Right? So either way is we not colliding or there's no issues here. So by the time this constructor finishes, we have an instance of this guy populated and an instance of this thing populated. So all our data has been extracted using reflection, stuffed into dictionaries, and from that point forward, we shouldn't have to touch anything to do with reflection. All right? And there are a bunch of other, or the other thing is the joined genres. I can explain that when we get to some code there. Essentially, it's being used at the time of throwing an exception. If you remember my video on exception handling, I talk about one of the requirements of throwing exceptions is you must provide a very clear message to the user as to what the problem was and how to fix it. And if there are possible values, like a finite set of values, then you should provide me with all those values. So we would like our exception messages to give us back, so we can include in our exceptions, the joined, string.joined values. Because this method is doing most of the heavy lifting in that case, which is here. And we'll go into the details of all these, but essentially it's these are ancillary methods and functionality that is required or that we want to build in, like the string parse to enum and enum to string. And there are a bunch of other things like validate and so on and so forth. I won't explain all the details here. This is plain simple C# code here at this point. So now let's see how this application is going to be used. So what we're going to do is we're going to use our genre parser, and let's ask it to parse the sci-fi version of it. And we want to get back an enum like that. All right. When you run this application, we'll debug into our parse method and see what happens there. Now, before the parse method is called, the static constructor is going to run, because that's how it works. And the static constructor is really where all of the reflection is occurring. So we want to make sure we debug into that too, so we can understand what's happening there. The parse method is simply using the two dictionaries that we initialize in the static constructor. So it's going to use one of those dictionaries to get back the enum here. So I'm going to go and put a breakpoint in the static constructor over here. And let's see how this runs here. All right, so we come in our constructor. We are saying for the type instance, get me the fields. And if you look at the fields, we will see that there's a collection of fields here. And this is equivalent to the number of enum elements we have in our genre. But if you looked at our sci-fi, you'll see that the name is sci-fi, right? So the property name is the as a string is sci-fi, and the type is really the field info singular, right? So for every item in this collection, this one field info will get the value, and the value is nothing but the genre itself. So we have to cast it to a genre because it comes back to us as an object. And that's the action. And on the same field info, again, we say get me the custom attributes. In this case, it should come back with an empty array. So that's an empty array. You can see the number of elements is 0. And so if the length is 0, it's going to come in here and it's going to add to our string mappings, which currently is nothing in there. It's zero elements in there. We say add the name, which is action, and the genre itself, which is the genre action. So we add that in there. We go around the loop and we come back with field info of comedy. There's no custom attributes to this as either. So we can simply run through this again. The next time around, we've got drama. Again, nothing different here. So we run through this again. And then the next time around, we've got thriller. Nothing new here again. Oops, did I miss? Oh, we've skipped sci-fi. Okay, the first time around is action. Second time around is comedy. Third time around is drama. Fourth time around is sci-fi. All right, this is the one we're interested in. So now when we say get custom attributes, because we got two of our attributes here, we should see 2 elements in the collection. So there's 2 elements in there. And each of these is the same type, of course, but one of them has a description property of sci-fi, and the other one has a description property of, the first one is sci-fi, and the second one has sci-fi. And this order is also important because if we flip this around in the way we define the attributes, this would change. And I can show you that. But for now, we just continue on with this. So you got 2 attributes. These are attributes, and they're not the actual enum elements. So it's not length of 0. So it's coming here. And over here, we'll say for the first one, we want to add that to the mappings. And this is sort of let's call it a design rule, if you will, that we've decided, or decision that we made. The first one is the one on the top. In other words, if you look at this over here in our genre, this is considered the first one. So if we flip the order of these 2 around, our results will change. But we're saying we want the first one to be sci-fi because that's the one that's going to be used as the string representation. At least that's as per the logic we have in our parser. So we're saying to the genre to string mappings, so given the genre of sci-fi, the string representation of that should be the first one. And that's description. Whereas for the reverse of that, the string to genre mapping, we iterate over the collection, and for each of those elements, we add in the description, the 2 lower version of that as the key, and then the actual genre itself is sci-fi. So the sci-fi on the value side will be available in the dictionary twice, but because the strings are different, we'll have 2, in this case, 2 entries. So if you look at here, so the first entry is going to be the description sci-fi, but it's mapped to the sci-fi genre. And the next time around, it'll be mapped to the description sci-fi, also mapped to the same genre, sci-fi. So effectively, we're populating these 2 dictionaries in the way we would expect. And eventually, or finally, we come in here, and now we want to get our genre values, and this method has been implemented over here. Essentially, it's just iterating over the collection of elements in the genre to string mappings, and it's going to get that converted to a string that is comma delimited. So it looks like that. action, comma, comedy, comma, drama, comedy, sci-fi, comma, thriller. And the reason for that is if we, for whatever reason, we want to throw an exception, we want to provide valuable, useful information in our exception messages, as I discussed in the exceptions video. You can see the link to that up here. And we would like to say something like, well, you gave us the wrong string. We can't map it to any valid genre. So here are the possible genres. Right? And that's the purpose of that string. And we construct the string at our static constructor time itself, and we maintain that as a private static member, read-only member in our genre parser. So all of the reflection aspects is done exactly one time. So we pay the penalty of reflection and the slowness of reflection, but we maintain that. So we're giving up some memory, or we're using up some memory here to optimize and thus not pay the price for reflection repeatedly. This is an implementation choice. All attributes don't have to be implemented like this. Some attributes, it may not even make sense to be implemented like this. In this case, it makes sense. All right. So if you look back in here now, if you put a breakpoint in here and run all the way up to here, we'll see that we've now got the sci-fi genre, whereas the string sci-fi. To double check the other sci-fi option, so if you did this, for example, now because I've stopped the application, so this time around I'll go and run the constructor, static constructor once again, because the app domain has been brought down or has been shut down. So when we rerun the application, the app domain comes back up, and once again this is going to go and get the static instance for the genre parser type. Also results in the sci-fi genre. Now if you wanted to see an exception being thrown here, so let's say I put in something that's not parsable, then we would like to see the exception message to tell us what happened, what we provided, and what are the possible values to help us fix the problem, if we possibly could fix the problem. All that's part of the exception handling video. Please take a look at that. If you are throwing exceptions in your system, you must always throw the messages of your exceptions should be very, very clear to help the user of your system or class or whatever it is you're building understand what the problem exactly is and how to potentially fix that problem. So if I run it here, we'll get that exception, and you can see the string skiff is not a valid genre. Valid values are action, comedy, drama, sci-fi, and thriller. There you have it. So that takes care of all of that. So this brings us to the end of this video. Now there are some thoughts you've been holding on to, right? Do you remember those thoughts? Okay, one of the thoughts was my love-hate relationship with attributes, and the second was my love and hate relationship with reflection. So here's what it is. With great power comes great responsibility. No, honestly. Systems can get this, all this looks very cute in the singular, meaning the one-off. So, oh my gosh, this is like a really cool thing. I can use it. And it certainly is a cool technique or technology. And it looks really, really useful in a small little system like this. In larger systems, this kind of magic becomes unmanageable. It makes systems unmaintainable, difficult to understand or comprehend, and on and on and on. Reflection has another problem, which is performance, and that the issues related around that. So as much as I love reflection and I love attributes, please, please, please don't use attributes and or reflection unbounded in your application. By unbounded, I mean you got to understand exactly when you should and should not use these things. These are very powerful features, capabilities in .NET. But there's a price to pay. Sometimes it's performance, most times it's maintenance. And maintenance is king. So now that I've said that, I've told you, I feel better. So go forth and conquer, and I shall see you next time.